What's up, math fans? I want to talk about absolute value functions today. Basically, I've been talking about linear functions a lot and all the different things you can do with linear functions. Find the slope, how they relate to real life situations, etc. But saying linear functions make you think that only thing exists is linear functions, and that's not true. There's a bunch of other kind of functions out there, and absolute value just happens to be one of them, so I'm going to introduce it today. We won't go too deep. And also, once you understand what an absolute value function is, then we're going to start to move it around and you'll see what translations of the function is. So basically, it's taking a v and moving it, and that's a translation. Translation is a movement of an absolute value function. All right, so let's look here at number one. This should look familiar to you as the same form as y equals mx plus b. This is a linear function where this is the slope, this is the y-intercept. 3 is your y-intercept. If you remember how that looks, and you might want graph paper or a graphing calculator for this, if you remember how this looks, when I type this in, my starting point is 0, 3, right here. 1, 2, 3, right here. And then my rise over run is 2 over 1, up 2 over 1, up 2 over 1. And you make your line, something like that. So my y-intercept is 3, all right? What I would call a parent graph is the graph y equals x. This graph, let me do it in a different color. This graph would go through the origin 0, 0. And this graph got lifted up 3 units, got translated 3 units. It actually also has a steeper slope than the green line. But right now I just want you to focus on the y-intercept. Here, the parent graph has a y-intercept of 0. Here, the graph has a y-intercept of 3. All right, now what about next one, number 2? What is your y-intercept in number 2? Is this even a linear anymore? No, but doesn't matter. This is still the y-intercept. So your graph is going to cross the y-axis at 3. It actually, if you get a calculator, a graphing calculator is awesome because then you don't even have to do much work. A graphing calculator, you will type this in and you'll see that it looks, that it looks like this, where the V starts or has a vertex here at 3. That's my 3. 3. All right, that was just an intro. You didn't really do any math yet, so now let's do some math. Oh, by the way, if you have a graphing calculator and you want to know how to type this in, these bars, those are the absolute value bars. You learned that in middle school. I would type, I would press the button that says math, and I would then look for where it says ABS. ABS stands for absolute value. All right, you might have to play with the categories a little bit. Okay, let me get rid of all this. And look at number 3. Y equals the absolute value of x. So I made a table of values, which you don't have to make if you know how to type it in the calculator. You type y equals, then you find the abs, and it'll automatically open parentheses, and then you just put x in the middle, close parentheses, and press second graph. If you press just graph, you will see a pretty picture. If you press second graph, it'll give you the table of values, and then you take those values and put them on a graph. So I'm going to run through it really quickly. I hope you remember this from middle school. Let's pretend x is -3. What's the absolute value of -3? What's the absolute value of -3? Positive 3. The absolute value is the positive distance from 0. So this is 3 units away from 0. So y would be 3. What's my point? -3, positive 3. Same for all of them. All right. So -2. The absolute value of -2 is positive 2. That gives you -2, 2. This one I don't have to show my work anymore, but I'll do one more time. Absolute value of -1 is positive 1. So that's -1, 1. 0, 0. Absolute value of 1 is still 1, positive 1. It's not the opposite, it's the positive value. So 1, 1, 2, 2. 6 points, put them on a graph. Guess what you're going to see? A V. Okay? Here's my x-axis, here's my y-axis. Here's 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. If you watch my stuff, you've seen this already. So this is considered the parent graph. Parent graph. And that's basically it. That is your absolute value function. It's a V shape on the graph, the end. The vertex is 0, 0 for the parent graph. This is your vertex, and that's the end. The rest of this stuff is just playing with it. So if I type this in with a +5, get my table, plot the graph, and you should pause it so you can do it on your own, you will see that same V, but guess where the vertex is? Instead of 0, 0, this thing took your old answers and added 5 to all these answers, to all these y values. So what happens is all the answers got lifted up 5 points. So 1, 2, 3, 4, 5. The green one is number 4, new vertex. Okay, so it took the parent graph and translated it up 5 units. Now, what do you think happens in number 5? Let's clear some space. It's going to take the parent graph, you should memorize this parent graph by now. Parent graph which has a vertex at 0, 0, and it's going to subtract 5 from all of my answers, so that brings it down. It translates it down 5 units. 1, 2, 3, 4, 5. My new vertex is here. Instead of 1, 1, I'm going to be at 1, negative 4. Instead of 2, 2, I'm going to be at 2, negative 3, etc. So it's a V that got pulled down 5 units. New vertex, 0, negative 5. Guess what happens if you subtract, guess what happens if you add 2 inside the absolute value bars? So you can do this a couple ways. You can make a table like I had a minute ago. You can type it in the calculator, or you can just learn the shortcut. Here's the shortcut. If there's a number inside, it doesn't move it up or down. It actually moves it left and right. And you might say, oh, positive, that's going to move it to the right. It's actually the opposite. When the number's inside, it actually does the opposite. +2 makes it go to the left. So instead of this V here, I take my vertex, I move it 1, 2 to the left, and it would look like that. That V is this. So you should now know that the vertex is -2, 0 instead of 0, 0. What's the vertex in number 7? It takes the parent graph, and wherever that parent graph starts, which is 0, 0 for the vertex, and this time -2 means we're going to move it up, no, down, no, left, left, no, to the right. It's the opposite of what you thought. Here my vertex is 2, 0. Here what was the vertex? 0, negative 5. Here what was the vertex? 0, 5. So this one brought it up 5 units like it looks like it, down 5 units like it looks like it, opposite. Left 5 units, left 2 units, right 2 units. What do you think the vertex is here? 2, 5. Opposite, same. That's basically it. That's your absolute value function and some fun translations of it. All right, thanks for watching. See ya.